चल रहा है क्या? How I will know? Give me your mobile. Okay, sorry for interrupt. Let me start it again. So we were discussing about the complexity. We were discussing about the complexity of first solution. So the complexity of first step is, you people tell me, n log n. Okay, and so what is the complexity of second step? Anybody can tell me? So this will confirm me that okay, still I am live or not actually. Okay, anybody please tell me, please reconnect and please tell me, okay, what will be the complexity of second step? For every day we are checking for n attractions. For first day, for second day, for third day, for fourth day, for every day we are checking for n attractions actually. Okay, so what will be the complexity for second day? That will be, okay, so that will be, let me tell you, that will be d into n. That's it. For every day you are checking n, you are taking n step. For day 1, day 2, day 3, day 4, day 5, for every day you are taking n step. You have d days. D into n will be the complexity of this second step. For first step you are sorting, that's it, n log n. Total complexity will be order of n log n plus d into n. D into n plus n log n, that is the complexity of this solution. Okay, and we will try to improve now this problem solution. We will, before going to the second solution, let's discuss about the code. Let's discuss about the same solution 1, this solution with code. Okay, that is very easy actually, very easy. So first what we were doing, you were sorting the intervals. You were sorting, interval means from starting day to ending day. You were sorting the rides according to their what? According to their happiness. And actually interval it is talking about, okay, starting day and ending day. We have 3 information about every ride actually. We are speaking ride to that. Okay, for every ride we have 3 information: how much happiness that is giving to us, and what is its starting day and what is its ending day. Okay, so that's why that is speaking it is interval. Simple, we sorted that. Okay, we sorted that. After that we are treating for d days, 1 to d, we are treating for d days. We will calculate happiness for first day, then second day, then third day, and then we will see which is having the maximum. First we will find out the happiness for first day. In this we will get the happiness of ith day, that is the first day, then second day, then third day, and we will store the result in one variable, answer variable ans, and we will check which one is maximum, this one, current one, or previous day happiness. Current day happiness, previous day happiness, current day happiness, previous day happiness. So we will check, we will compare which one is maximum. That will be our answer. That's it. Sorted the elements, and then for every day check the happiness and compare all the days happiness, day 1, day 2, day 3, which one is having maximum. That is the answer. That's it. So how we are calculating the happiness for one day? We also know that thing. In the starting I set the happiness for ith day, for first day let's suppose 0, and after that I am checking for n rides. We were checking for n rides. For every day we are checking for n rides. So I will, for first day, for ith means, okay, for first day I am checking for n rides. And but those rides, I will consider those rides which will lie, which will become. I will consider only those rides which will happening on that day. Okay, how I will find out, okay, this ride is happening on that day? Simple, I check by this condition. What this condition is doing, okay, starting day of the ride and ending day of the ride must be lie here. Means starting day must be less than equal to current day, and ending day of the ride must be greater than equal to current day. If our current day is lying in this period of the ride, then that's it. Then we consider it as happiness. We will add its happiness. Okay, and we will keep doing this again and again. And what is this count? This count is actually counting. We need to take k rides only. Maybe we are having more than k rides on that day, but we will take only k rides. So whenever we will get k rides, we will break out of this loop for that day. And that's why we are using count variable here. Count in the starting we have 0. If that will reach to k, we will break out of the loop, and we are counting that. That's it. So this is the same thing. The code is doing the same. If you are able to understand this code, please write +1 in the live chat. Please write +1. Everybody, please let me know if this code is clear to you people or not. Please let me know. We need to connect with each other. See, we need to connect. Anybody? Anybody, please tell me. Otherwise, I will come to your side. Please tell me. Whether you are able to understand this or not. Okay, let's move. So this is the solution. This is the code for first solution. Let me take the second solution, which is very, very easy actually. You can see here that is there are only 7 steps, and that is very easy actually. You can see the screen itself. That's looking very easy. Actually, you will not believe me. Really, that solution is easy. Let me tell you. Let me explain you the second solution directly. Okay, let me explain all these 7 steps of the second solution with some diagrams, and that will be clear to you. What we will do in second solution, one thing is clear, we know the problem. What is the problem? Okay, we need to maximize our happiness by taking k rides on one day. Out of D days, I need to go for one day to the festival, and I will take k rides, and those rides will give me maximum happiness. So this is the question. Okay, so what I will do, see what we will do. First step, only 2 steps are actually, only broadly if I classify all those 7 steps, only in 2 steps you are working, and I'm telling you those 2 steps. Okay, first one is see what you will do. You will take an vector. Okay, you can say vector. So this is just like an array. If you don't know vector, no problem. And I will store the information of all the days in this: day 1, day 2, day 3, day 4, day 5, day 6. How many days I have? Okay, let me take day 6 up to day 6. Let me write here. So in the first step, what I will do is, let me convert it in the form of matrix, so that this data will be clear to you people. I'm taking 6 days, up to take 6 days. Okay, you can take for more days also. I'm taking one example, that's it. Okay, so what I am doing is, in this vector I will create the vector of multi sets. So sets, if you don't know about sets are nothing, just they are just like mathematical set. Okay, but here the elements are sorted. One thing is that elements are sorted. And the second thing is that you can find out any element in log n time. Okay, you can find out or you can update any element in log n time. So that's why actually this will help us to reduce the complexity. This will help us to reduce the complexity because this take log n time to perform the operations. Okay, no problem. If you don't know, no problem. Simple. This is just like a mathematical set. What I'm storing here for all the day. Simple. Keep it in just like in English we are talking. For all the days, I will store okay which ride is occurring. What is the starting day of any ride and what is the ending day of any ride? We know that for every ride. Okay, for every ride we have some starting day and some ending day and some happiness for every ride. Okay, for every event, ride, whatever you can say, n1, n2, n3, for everyone I have happiness, starting and ending day, and some happiness ratio. So here what I am going to do, simple, I am storing what is the starting and ending of any ride. Let's suppose I have n rides, n1, n2, n3, n4, so on I have. So let's suppose for n1 ride starts from day 1 and ends on day 4. Let's suppose n1 ride starts from day 1 and ends on day 4. So how I will store it? Okay, how I will store it? See, so n1 I'm talking about. So rather than storing n1 here, I will store its happiness here. So happiness of, let's suppose, first ride. I will store the happiness of first ride, and I know that will start on day 1 and that will end on first ride will end on day 4, starting from on day 1 ending on day 4. This information I am storing. So how I will differentiate between, okay, this is the starting day, this is the ending day. I will store this result in minus. Okay, ending day I will store with minus. What I am doing, I am repeating, simple. I am storing for every event what is their starting day, what is their ending day. That's it. But rather than storing n1, n2, n3, I am storing its data. I am storing its happiness. So from h1 I can find out, okay, I am talking about event 1. I am talking about n1. I am talking about ride 1. And why I put minus here? Because this is showing that first ride n1 ride starts on d1 and end on d4. And why I am storing h1? Why I am not storing n1 here? Because I need h1. I need the happiness. I need the happiness. I need to calculate the maximum happiness. So rather than storing some dummy data n1 and n2, I am storing happiness there. Okay, I will do this for all the events actually. Okay, let's suppose let me take the second event n2. N2, let's suppose, start from d1 and ends on d3. So I will write, okay, its happiness is, let's suppose, h2 and its end on d3. So minus here. Okay, and let's suppose n3 starts on d2 and ends on d5, starts on d, this is an h3. Okay, let me write here so this will be clear to you. h3 starting on d2 and ending on d5. Simple. Keep it very simple. Don't confuse in it. Okay, keep it very simple. I am simply storing which event is starting day and ending day with the help of their happiness. Actually, I am storing their happiness. From their happiness I can find out, okay, I am talking about event 3. Its starting day is 2, ending day is 5. So on I can store. Maybe okay, event 4 is starting here and maybe ending here. Okay, and event 5 maybe starting here and maybe ending here. Okay, so you similar way you can store different events. Okay, so this is the first step. That's it. This is the first step. What I will take, if you will talk about programming point of view, I will take a vector of multisets. I will store for different days, for all the days I will store. Okay, for different events, for different rides, I will store their starting and ending, starting, ending, starting, ending. Okay, in place of their starting, ending, I am storing their happiness, 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 and minus shows here that is the ending day of that event. That's it. That's it. First step completed. Second and last step. Second and last step of second solution. What we will do here is that we will take two sets, two multiset, one multiset, two multiset. That's it. And we need to perform some operation in this. Okay, so we will take two multiset. This is one multiset, this is another multiset. Its name, let's suppose, is important. This is important one. Actually this multiset, this is a data structure. This multiset will give us the solution. This will give us the answer. We will get the answer from here. Okay, and the pen is again not working. Erase and then again use pen. Okay, so let me try once again. Let me use pen from here. Okay, so answer will be, so this set will give us the answer. Answer means maximum happiness I will get from this multiset, and this multiset name is lose multiset. This multiset name is lose multiset. This will help me to this will help me actually find out k. I can say, okay, this will help me to maintain this lose multiset will work with the coordination of this important multiset. This will help this multiset. That's it. This set will help this multiset to perform the operation, to get the answer. Okay, let me see how we will store the data in these two. We have two multiset. That's it. We know this thing. Okay, its name is important. Its name is lose. Okay, what we'll do now? Now we will iterate day by day. Day 1, day 2, day 3, day 4, day 5, day 6, so on. Okay, for first day, let's iterate. What I will do, simple. I will put various rides which is starting on day 1 in this set. Okay, I will write which ride is starting. H1 is starting, so I will write H1 here. H2 is starting here. Okay, H4 is starting here. I will insert these rides here in these multisets. Okay, so after inserting, I'm winding up now. Now I'm winding up. I take two sets, two multisets, iterating for each day. I'm showing you for one day, first day. Simply I put all the happiness, all the events which are occurring on day 1 in this multiset, and I sum these. Actually, out of these events, I will sum k. I will sum k top events, the events which will give me the maximum profit. Okay, maximum happiness. Out of these, let's suppose these are the k events itself. K events. I can insert n events. Actually, we can have n events in a day. We can have n events in a day. But how many events you can visit? How many rides you can take? You can take k rides only. So I am taking k rides, and I am adding those k rides, and I am getting the happiness. Happiness for, let's suppose, day 1. I get the happiness for day 1. So when I get the happiness for day 1, similarly I will do for day 2, and then when I will get the happiness for day 2, I will compare, okay, which one is maximum. Whichever will be the maximum, I will store that into one variable answer, and similarly I will come with the next day 3. Then I will compare my answer with day 3, and then with day 4, then day 5, whichever will be maximum, that will come in this variable, and simply I will print that. Okay, so this is one thing is going on. This is one thing is going on. We will see this thing. We will check this thing. Okay, but there can be many some conditions may occur while performing this task. First condition that may occur is, let's suppose we have done with day 1. Okay, we done with day 1. We inserted it. We find out k. Let's suppose k are these 3 are k rides. I sum them and I store the result into answer. That's it. Day 1 finish. After that, I take day 2. Which are the events are occurring on day 2? H3 is occurring on day 2. H3 is occurring on day 2, but you find out that we cannot insert H3 in this. Why? Because this is, let's suppose, already full. This is already full. The size of this set is, let's suppose, k. The size of this set is k, because we want k only. We are going for k rides only. Okay, so this set is helping us to finding out k rides which give us maximum profit. That's it, which give us maximum happiness. So this is already full. This, let's suppose, this can have 3 rides only. K value is 3, let's suppose, only. Then you are trying to add H3 also, but we cannot add H3 here. But there may be condition that H3 can give you more profit, maybe, rather than these can, out of any of them can give. So actually the elements, I have tell you that elements in the multisets will be sorted. Okay, they will be sorted. So let's suppose H1 is having the minimum value. So what we will do now, we will replace H1 with H3. 3 elements can come only in this multiset. So I need to insert this H3 in this, because H3, I find out that H3 having more happiness than H1. And H1 is the lowest happiness value in this important set. So in this important set, H1 is the lowest happiness value. So I will replace this with H3. Okay, and then what I will do, I sum H4, H2 and H3, and I will get the happiness for day 2 now. Okay, and I will compare that with day 1. Which one will be the maximum? I will store in this variable. Okay, that's it. Okay, one condition we have covered up. So this condition may occur. If this set is full, then what we will do? There is one more condition. What is that condition? Now where this H1 will go? Actually we will not throw this H1 just out of this multiset. We will store this H1 here in this loose set. Why we are storing this H1 here in this loose set? Because we are storing this H1 in this loose set because maybe this H1, okay, maybe less than H3, maybe that can be less than H3, but that may be having higher value than other rides, maybe H5. Maybe that H1 is having greater happiness than H5. So maybe that can be used later. So in that case, I will shift it from here to here. So simple what I am saying that when we are inserting H3 here, so I will take minimum event from here and store that into another multiset. Okay, and then store it here. Okay, this condition is done. Okay, now let's move to day 3. One more condition will occur now. Now we are getting the end. What if we are getting the end of an event? So if you are getting the end of an event, so first I will check these events into my loose set, because this is one extra set. This set is helping this important set to find out the solution. So if these events which are ending, how I find out these are ending? Because they have minus in front of them. If they are ending, I will check them in loose set. If they are available in loose set, I will remove them. What I will do, I will remove those events from the loose set, because that event has ended now. Okay, but if that is not available here, you can see that is not available here. Now we will check in the important set. In important set, I will remove H2 and H4 because both has ended. Both have ended. Only H3 now we have. Okay, and what I will do then now, after removing this, there will be space in this because we can, here in this case, in this example, we have 3 k value 3. So I will insert H1 now here. I will shift H1 here. Okay, because H1 event is still going on. H1 is not ended. So so H1 I will add H1. So this is one another condition if you will get the event is ended. And here H5 you will add H5 also because that is occurring. Now you will get sum up all these three, the happiness of all these three, and compare which one is maximum and get the answer in this variable, answer variable. You will do this for all the days, for next day, for next day, for next day. So from this way you can find the happiness. That's it. This is how second solution is working. Okay, and the complexity of this algorithm will be actually you are working for D days. You are working for D days, and for D days, how many operations you can perform maximum? Actually, you can perform log n operation. Okay, so this will be the complexity. First of all, you are performing n also. For first step the complexity will be n. For the second one, the complexity will be d log n. So this will be your total complexity. Okay, so these only two steps are there. Okay, let me show you all this thing. Maybe how to rub this clear. Okay, so let me show you all this stuff in the previous slide. If I can move to the previous slide. Let me restart it again. Okay, this whatever I have explained you is written here. This is what we have done actually. So you can relate somehow. I'm taking 2 more minutes to explain these points so that if you will be able to connect more actually. Okay, so what we done in the first step is, in the first step, let me use the pen. In the first step, actually you are storing this, you can see, okay, happiness on day basis. You are making an array or vector and you are storing all the happiness. Happiness means starting and based upon starting and ending value. You are storing the happiness everywhere in the first step. This is the first step actually. This is the first step. That's it. Okay. In the second step, you were using 2 multisets. You know, you were using 2 multisets. One was the first multisets was you were helping us to find the highest happiness ratios. We were adding the highest happiness ratio. How many highest happiness ratio? K happiness ratios. K. We were storing only K elements in that. Okay. And the second was actually helping us to keep track of the active rides, which rides are active, which rides are still active, and our first set is full, then we were transferring them to the loose set. If our first set is full but the ride is active, then we transfer it to the second set, so that maybe we need to use that in the first set again. Okay, so this is, we were using two sets, two multi sets. After that, what we are doing, we will iterate through all days. Yes, we were iterating from one day, second day, third day, fourth day. We were comparing their maximum solutions, and which were, and the end, after comparing all the days maximum happiness, whatever we were getting, that is our answer. Okay, so what we were doing now in these three steps, 4, 5th and 6th, you are simply comparing various conditions which I explained you. Maybe condition like, maybe your first set is full, means k element so is already there. Then what you will do, you will delete one element which is having lowest happiness ratio and store that into the loose multiset. Okay, you will do something like that. What you will do, if you will get the end of an ride, or you will get minus happiness, then what you will do, you will remove it, try to remove it from the loose set or from the important set. Okay, so this is what is explained in 4th, 5th and 6th. Okay, let me read for you people this also. If the current day is the starting day of an interval, then if the number of active interval in the first multiset is less than k, we will insert the interval in the first set. This is very simple actually, what it is talking about up to here. Up to here is that he is saying that our first multiset, important multiset, is empty, that is having values less than k. Then so we will store the result, we will store the event in that multiset only, in important multiset only. That's it, but it is saying. But otherwise, if the interval with the smallest HR has a greater HR than the interval, then we will insert this interval in the second multiset. And okay, what it is saying that if we are, let's suppose our first multiset is full now, okay, and you get another, you get another ride which is having higher happiness than the happiness ride which is available in your important set, then you will remove the lowest one from the important one and put it into the loose one. This actually is doing all those steps which we perform in our example actually. Okay, this is all what I is doing, and after that, that is summing all the results and giving the maximum, comparing all the days happiness and summing, giving the results. I just write all these steps. Open my account, let's go. And we were working for round F. Yes, this one, round F, Google KickStart. This one we are checking for the code actually. Okay, now round F, let me see, festival problem, and it is not showing my code. Actually, that code is also available on my ID. Let me check out there. Okay, let's end this session here only. We get the idea. Okay, how we can have different solution for this problem. Okay, okay, best of luck for your next Google Kickstart round. Please prepare yourself with the basics of the C++. You need to know C++ STL. If you are competing for Google Kickstart, you need to prepare, that is the base. You need to prepare for competitive programming. You need to have data structure and algorithm basics should be clear. So in the last session I tell you that okay, the language is must, data structure and algorithm is must, and CP competitive programming is must. Go through them. If you will start preparing from today only, then in 6 months you will be good at this, and in 1 year you will be at master at this. So after even 1 year, if you are getting placed in Google, that is much better than rather than working with any company. Okay, so if you want to go for competitive programming course, that is one available from our side also, that is from Joseph Amritraj. All the detail is given in the description, you can check out there. Okay, so best of luck for today. I'm ending this session here only. Thank you.